Hello and welcome to this video analysis of this absolutely spectacular crash of a Canadair Regional Jet 900 that was supposed to make the trip between Minneapolis and Toronto, and as you can see it ended up upside down after a failed landing. Fortunately, there were no fatalities among the 80 people on board the aircraft. We will analyze how a plane can end up upside down, particularly by examining a precedent that occurred in Somalia in 2022. So first we need to understand what this aircraft is. The CRJ-900 in question is operated by Endeavour Airlines for Delta Airlines. The flight was to travel from Minneapolis to Toronto, a short and familiar route. Using only the data available on the morning of February 18th, we will attempt to comprehend the potential sequence of events. First, we have a descent rate, which, according to the elements that are sent back by the plane at different pings, and which are captured by sites like Flight Radar 24 thus, we have a descent rate which is 1,000 feet per minute instead of 400 feet per minute at the same moment of the approach when we compare it with the previous planes. So that is to say that certainly the descent rate was above what is classic for this type of landing. The second element, besides this high descent rate, is what we call the rounding. That is to say that when a plane is going to arrive on a runway, it is not going to continue with the same angle of descent. Normally, it is going to break its angle to be a little more horizontal, to reduce its vertical speed, to reduce the impact with the ground. But here, we have a surveillance camera that shows us this image in which we get the impression that the plane is going to continue with its initial angle. That is to say, it is not going to make its rounding. And so logically, if we already have a descent speed that is higher than average and there is no rounding, you have a very intense impact with the ground, which will lead to the destruction of the landing gear. And the question that comes to mind now is, how does it happen that the plane will end up sideways, eventually losing its wings and rudder and stabilize upside down? So first we need to look at the conditions of the runway. We are on a runway that is with snow that is frozen. We can see that from the images, which are after the evacuation, and we have wind, which is announced by the control tower coming from 270 for 33 knots. However, the landing was made on runway 23, that is to say 230 degrees of magnetic orientation. That is to say that we potentially have a 40-degree difference between the wind and our plane at the moment of the landing, so you roughly divide the wind force by 2. When we have 33 knots, that is to say 60 kilometers per hour, well, the wind, the cross component of the wind that is endured by the aircraft is around 30 kilometers per hour, or rather 16, 17 knots. The problem is that on this type of aircraft there are limitations, and the limitations for a wet runway are 22 knots crosswind, which here is apparently respected. But on the other hand, when there are reduced braking conditions, it's rather 15 knots. So in absolute terms, we are not on proportions that are sufficient to overturn the aircraft, but we must also understand how planes are going to land when they have crosswind. Either they land with an angle that is oriented from where the wind comes, and at that moment it's once the plane touches the ground they will get back on track, or they will land crabwise and they will decrab just before impact to face forward to land properly on the runway axis. And here in the image we have once again, which is perhaps not precise enough, but we don't really have the impression that the plane has its nose oriented from where the wind comes, nor that it tries to get back on track once it's going to touch the runway. But in any case, the most likely element is that one of the two landing gears will undergo an impact that will be more intense, and so it will give way under this shock, because again we arrive at a high speed and without having a flare, which may not be due to the pilot. Maybe it's what we call wind shears. That is to say, these winds that will push us towards the ground when arriving on the landing, one of the two landing gears will give way, and we have the plane that will go sideways. And there the wings will tear off, the rudder will tear off, and it's made for that. That is to say, after decades and decades of having accidents, there have been requirements that have been put in place. One requirement is that the wings give way to prevent a secondary accident. And the wings contain some of the fuel, so there is also some of the fuel that will not feed a potential fire. So you still have a fire. We see it from the outside because the passengers of the other planes around are going to film the scene, and we see this large amount of fire. But once the plane is stabilized, you have the firefighters who are going to arrive very quickly, and we see that they are spraying the fuselage of the plane, or what remains of the fuselage, upside down with this foam that prevents the resumption of a fire, or that it will trigger. And the evacuation takes place in a way that is calm and admirable. That is to say, we have videos that are filmed by the passengers themselves during their evacuation, and in which we see that the crew members are doing exactly what they are there for. They ensure the evacuation under conditions that are optimal. So once again, the crew members, the hostesses and the stewards, they are not there to serve coffee. They are there above all to ensure safety. So now, are there any precedents? Well, there is one at least that took place in the summer of 2022 in Somalia with a Fokker 50, in which there was a very strong crosswind that caused one of the two wings to touch the ground. The plane ended up once again on its side, and you have exactly the same phenomenon. That is to say, you see it here, you have the disintegration of the plane, but only its wings and tail. The fuselage is protected and tarpaulins will be used to cover it, similar to a car. The plane will stabilize on its back and crews will intervene quickly. The wings are designed to brake to protect the fuselage. Inside the plane, the seats can withstand 15G, so as long as passengers are wearing their seatbelts, they will remain in their seats without being thrown around, preventing secondary accidents. And from the moment the fuselage itself is fireproof, that is to say, it is made to resist the combustion of fuels for more than 90 seconds. There is no explosion because there are additives in the fuels to no longer have the explosions, as we had in disaster movies in the 50s, so the plane does not explode. The plane protects the personnel inside to avoid fire, the belt, and the seats make sure that people are well wedged. And that's why there are only a handful of minor injuries. There is one injury that is relatively serious a priori, and there are 8 minor injuries, and all the other people will be able to get out of the plane under perfectly normal conditions by walking. So here we can objectively once again talk about a miracle, but it's a miracle that is brought about by years of experience and feedback on air safety to always improve it. The questions that will now arise are whether the runway, in any case, whether this plane should not have been allowed to land, given the contaminated runway, given the crosswind gusts. Was the crew descending too fast? Are the information we have on the 1,000 feet per minute, is that correct? Is the plane's radio sonde, can we imagine that the system that allows to radarize the ground to know its altitude, could it possibly not work, and therefore they did not have correct information about their altitude? Did they miss their rounding, or did they suffer a wind shear that pushed them towards the ground? So there are many elements on which we obviously have no answer today. But on the other hand, be convinced that this is a particularly rare event, which did not do any harm. Again, I emphasize that you will not encounter at other airports, because here we are in very particular conditions of icy runways, of the weight of the plane, of the type of aircraft, of crosswind, and you cannot reproduce these conditions at another airport. And therefore, above all, be convinced that whatever the aircraft on which you will fly, if you have to take the plane tomorrow, you will be safe. Never cancel a flight to take the same route by car or even by train. The risk is statistically higher. But above all, do not believe that this is an event that will recur, that we will see regularly. There was a case in Somalia with really weather conditions that were particularly degraded. We have this case which has not caused any deaths, and fortunately so, you can travel calm and happy. You have no risk that your plane will have the slightest problem tomorrow. We will soon create an Airbus Safety Promotion Center video. The editing is in progress, so you will also see how after years and years of experience we get to these accidents which, even when they occur, manage to cause no casualties. I hope you enjoyed it, and I'll see you very soon.